Hello everyone. Thinknyx welcome you all to this interesting tutorial on Docker, a revolutionary technology that has transformed the way we develop, deploy, and run applications. In this era of rapidly evolving software and complex infrastructure requirements, Docker has emerged as a game changer, providing a standardized and efficient approach to build and manage software containers. But what exactly is Docker and why has it gained so much popularity in recent years? Let's discuss that here today. I'm Deepti Narayan and this video is prepared under the guidance of our CEO Yogesh Raheja. Let's take a look at the agenda for today. First, we will understand what the problem was with the traditional approach and how containers are helping in resolving this issue. Later, we will discuss what Docker is. We will also understand what image registries are and what are the different types of public registries. In the later part of the video, we will understand Docker architecture, and at the end, we shall discuss some of the features of Docker. Let us now understand what are containers. Imagine you have a bunch of different applications that you want to run on your computer. However, each application needs specific settings, libraries, and dependencies to work properly. It can quickly become a mess to manage all these requirements and make sure everything runs smoothly. Now, think of containers as little virtual boxes that can hold each of these applications separately. Each container contains all the necessary things the application needs to run, like the code, libraries, and settings. It's like having a self-contained mini computer just for that application. The great thing about containers is that they are isolated from one another, meaning they can't interfere with or mess up each other. So you can have multiple containers running on your computer, each with its own application, and they won't cause conflicts or confusion. How can we define containers? Containers are lightweight, isolated, and executable software packages that contain everything needed to run an application, including the code, runtime, system tools, libraries, and dependencies. Containers provide a consistent and reproducible environment, allowing applications to run reliably across different computing environments from development to production. Let us now understand what Docker is. Docker is a platform to build, ship, and run containerized applications. So what does this mean? Docker gives us the flexibility to use a text document called a Docker file. This document has instructions which we can bundle them into binaries. This binary is nothing but an image. To run a container, the minimum requirement is an image. Docker gives us the flexibility to build that image using Dockerfile. Once the image is built, we can share that image. This is nothing but shipping. The shipping can be done using a registry. You can relate this to GitHub, where you can store your source code into the repository. To share your images, we use a registry. The Docker Hub is one such example. Anyone can take that image and create a container out of it. Container is a running instance of your image. Image is a read-only template. The container is a read-write template. If containers are running, that means our applications are running. Thus, Docker is a platform as it not just helps us to create the containers, but also build, ship, and run the containerized applications. Let's talk about image registry. A Docker image registry is a centralized repository that stores images, allowing user to easily distribute, share, and manage container images. There are two main types of Docker image registries, public and private. Let's discuss public registry. Docker Hub is the default and the most widely used public Docker image registry. It hosts a vast collection of pre-built Docker images. Docker Hub allows users to search for images, pull them to their local environment, and contribute their own images to the registry. In Docker Hub, you will find different types of images that serve various purposes and technologies. Here are some of the common types of images available on Docker Hub. Official images. Docker Hub hosts a set of official images that are maintained and verified by Docker. These images cover a wide range of popular software and technologies, including operating systems such as Ubuntu, CentOS, programming languages such as Python, Node.js, databases such as MySQL, PostgreSQL, web services such as Nginx, Apache, and many more. Official images provide trusted and reliable base images for building containers. Next is verified publisher images. They are high quality images from the commercial publishers verified by Docker. These images help development teams build secure software supply chains, minimizing exposure to malicious content early in the process to save money and time later. User images. Docker Hub allows users to create and publish their own custom images. Users can build Docker images locally and then push them to the Docker Hub for storage and distribution. User images can be shared with others or kept in private for personal and organizational use. Let's now discuss Docker architecture. Whenever we come across the term Docker, the reference is to the Docker engine. The Docker engine is the core part of our Docker ecosystem. The Docker client is a command line tool that provides an interface for the users to interact with the Docker daemon. It sends command to the Docker daemon via the REST API calls. Docker daemon is the heart of the Docker engine and it will do all the heavy lifting for us. For example, the Docker daemon manages the Docker objects such as containers, images, networks, and volumes. Once done, it will pass the control to Containerd. Containerd is an open source container runtime developed by Docker. It acts as an intermediate layer between Docker daemon and the operating system's kernel. Containerd is responsible for managing the lifecycle of containers, including container creation, execution, termination, and garbage collection. Containerd will make the architecture daemonless. Even if the Docker daemon is down, the Containerd still continues to take care of all the running containers. Another important component in the Docker architecture is runc. It is responsible for spawning and running containers. The primary function of runc is to interact with the underlying kernel to create lightweight isolated environment. These lightweight isolated environments are nothing but the containers. As soon as the container is created, runc process will exit. The runc is the replacement of libcontainer, which was part of the old Docker architecture. Together, Containerd and runc play crucial roles in Docker architecture, enabling container creation, management, and execution. Let's discuss some of the popular features of Docker. Speedy recovery. Speedy recovery in Docker involves taking measures to quickly restore services and minimize downtime in case of failures or issues. For example, Docker provides restart policies that define the behavior of containers when they exit or encounter errors. By configuring appropriate restart policies such as always or on failure, Docker can automatically restart containers that have failed, reducing the manual intervention required for the recovery. Next is portability. Docker enables applications to run consistently across different operating systems, cloud platforms, and infrastructure environments. Containers encapsulate the application and its dependencies. Say, for example, we can run the same containerized application on data center as well as on cloud without any modifications. Next is cost optimization. Docker can help in cost optimization by providing several features and capabilities that contribute to efficient resource utilization, streamlined infrastructure management, and reduced operational costs. Docker works well with container orchestration platforms like Kubernetes or Docker Swarm. These platforms provide advanced scheduling and resource management capabilities, allowing you to optimize the placement of containers across your infrastructure, distribute the workload evenly, and efficiently utilize available resources. This optimization reduces infrastructure costs by making the most efficient use of resources. That's it for today's video. Let's recap what we have learned so far. We understood that containers are lightweight isolated environment inside which our application will run. Then we discussed what is Docker. Docker is a platform to build, ship and run containerized applications. We later understood some common types of images available on Docker Hub, like official images, verified publisher images, and user images. Post that, we discussed Docker architecture. We spoke about components such as Docker client, Docker daemon, containerd, and runc. At the end, we discussed some of the Docker features such as PD recovery, portability, and cost optimization. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and subscribe to our channel. Also, don't forget to hit the notification bell so you never miss an update from us. Stay tuned for more exciting content coming your way. Take care and see you in the next video.